And welcome back to Teacher Gimble's channel. Today we're going to be going over Illustrative Math, Algebra 1, Unit 2, Lesson 2. We're going to be doing the practice. If you like this video, make sure to like and subscribe so I can keep making more like it. Let's get started. Problem 1. Large cheese pizzas cost $5 each, and one-topping pizzas cost $6 each. Write an equation that represents the total cost T of C large cheese pizzas and D large one-topping pizza. So the total cost is going to be T. It's going to equal the cost of the number of cheese pizzas you make, and we're going to multiply this number by $5. The reason for this is because for each additional cheese pizza you make, you pay another $5, plus the number of large one-topping pizzas you get, which is represented by D, and we're going to multiply this by 6 because for each extra large topping pizza we get, we add another $6. So the total cost for your large cheese pizzas plus your one topping pizza is going to be T is equal to 5C plus 6D. Let's go on to the next question. Jada plans to serve milk and healthy cookies for her book club meetings. I love that they are healthy cookies. She's preparing 12 ounces of milk and 4 cookies per person. Including herself, there are 15 people in the club. A package of cookies contains 24 cookies and costs $4.50. So she's preparing 12 ounces of milk and 4 cookies per person. A 1-gallon jug of milk contains 128 ounces and costs $3. Let N represent the number of people in the club. So I like to write this down. All of my variables. M represents ounces of milk, OZs of milk. And C represents the number of cookies. C equals number of cookies. And then B represents Jada's budget. Jada's budget. Definitely spelled that wrong. Select all of the equations that could represent quantities and constraints in this situation. So here we have M. M is going to be ounces of milk. So 12 ounces of milk times 15. So let's think. If she has 12 ounces of milk per person and 15 people, so this would be OZs, and this would be the people. This would be the amount of milk that she needs. So yes, this could represent the quantity and constraints in this situation. B is equal to 3M plus 4.5C is equal to B. So B is Jada's budget. 3M represents $3. Well, in this case, 128 ounces cost $3, whereas M just represents the ounces of milk. So this 3M is not a correct representation of the amount of milk or the cost of milk that you're going to get. So I'm going to cross out this answer right away. C, 4N is equal to C. 4 times N, so the people in the club, is equal to C, which is the amount of cookies. Well, if we have 4 cookies per person, and we do 4 times the number of people, we should get the number of cookies that we need. So this is correct. It's super helpful to always write out your variables to easily go back and check them. D, 4 times 450 is equal to C. So in this case, the 450 is the cost of a package of cookies, and C is the number of cookies. Well, 4 times 450, that's going to give you the cost of a cookies for some people. Well, that's actually not going to get you anything because there's 24 cookies in a pack. So I'm going to cross that out. Now let's look at E. B, which is Jada's budget, is going to be 2 times 3 plus 3 times 450. Well, her budget is going to be 2. I don't even know where that 2 came from. The 3 represents the $3. So maybe she's buying 2 containers of cookies of 2 gallons of milk, which is 128 times 2, which is 156 gallons of milk, which does that allow 12 ounces per person? Well, 12 times 15 is the amount of milk that we need. So we're going to require to do a little bit of math here, which is okay. That's a 6. Well, that's 186 plus 3 times 450 means she got 3 packets of cookies, which would be 24 times 3, which in this case is going to be 82, and 4 cookies per person, so she'll need 4 times 15, which is 60 cookies. So it's enough cookies, but it doesn't seem to be enough milk in this situation. So it's possible that she brought 2 gallons of milk and 3 containers of cookies. So I would say that this makes sense, even though we don't quite end up with enough milk. If you have any questions, please pause this video. I did my calculations on the side, so you could see exactly what I was doing to determine the correct answer to this question. Let's go on to the next one. Problem 3. A student on the track team runs 45 minutes each day as part of her training. She begins her workout by running at a constant rate of 8 miles per hour for A minutes and then slows to a constant rate of 7.5 miles per hour for B minutes. Which equation describes the relationship between the distance she runs in miles D and her running speed in miles per hour? So let's go ahead and analyze the equations to determine the correct answer for this question. We have A is equal for minutes per mile, or just minutes. And then we have B is equal to minutes. So A is minutes at 8 mph, miles per hour, and B is minutes at 7.5 mph. So we have an equation to describe the relationship between the distance she runs and her running speed in miles per hour. So E represents distance. So let's look at our answers. A plus B equals 45. Well, that's the number of minutes that she runs will be 45, but that doesn't give us anything about the distance she runs. Here we have 8 times A, so 8 times A, which is the number of minutes she runs, plus 7.5 times B, which is the number of minutes she runs at the second speed, equals D. Now, I do like this answer, but I have to be careful because I see that here I'm given minutes, and here I'm getting miles per hour. So our units are different. So because our units are minutes here and miles per hour here, this equation doesn't actually work. Because what we need to do is we need to convert our minutes to hours. Now to convert our minutes to hours, we're just going to put it over 60. So to have our minutes in hours, we're going to put it A over 60. That's going to be the percent or the quarter or the fraction of the hour that she's actually running. So now here, 8 miles per hour for A hours plus 7.5 miles per hour at B hours is equal to D, which gets us our correct answer. So you got to be careful, especially when you're doing rates, that your units are always matching up. Now let's look at our final answer. 8 times 45 minus B plus 70.5 B is equal to D. So 45 minus B is just saying the amount of minutes she ran not at speed B, which is the same thing as saying A. However, this doesn't actually help us solve the question because this is the same as B and our units are not correct. Pause the video if you need to go over this or think about the reasons to this answer while I move on to the next one. Elena bikes 20 minutes each day for exercise. Write an equation to describe the relationship between her distance in miles D and her biking speed in miles per hour when she bikes. 1. So, she bikes 20 minutes a day for exercise. We need a relationship to describe the distance in miles per hour. At a constant speed of 13 miles per hour for the entire 20 minutes. So she does 20 minutes. And again, just like we said before, it's 13 miles per hour. So we're going to say it's going to be 20 over 60 because she goes for that much of an hour times 13 miles per hour is going to equal her distance. And this is because distance is equal to rate times time. So that's a handy dandy useful equation to remember for these types of questions. 2. At a constant speed of 15 miles per hour for the first 5 minutes, then at 12 miles per hour for the last 15 minutes. So our distance here is going to be rate times the time. So for the first 5 minutes, that's 5 over 60, because we're turning it into an hour, times our rate, which is 15 miles per hour, plus for the next 15 minutes, we're going to say 15 over 60, convert that to an hour, times our second rate that we're going, which is 12 miles per hour. That sounds like the type of run that I would go on, but this is biking speed. At the constant speed of miles per hour for the first 5 minutes, then at n miles per hour for the last 15 minutes. So we have a constant speed, so distance. Again, for the first miles per hour, we're going at some distance that we don't know. Well, we're going at some speed we don't know, but we know it stays the same. And then we're going to go for the next 15 minutes, 15 over 60, at a second speed, which is n. So we can write this equation with terms of variables, which is correct. Now, I didn't simplify my fractions, but I trust you guys to be able to simplify your fractions from earlier lessons. If you have a problem with simplifying fractions, let me know, and I can make an extra video to help explain how to do that as well. Problem 5. The dot plot displays the number of marshmallows added to hot cocoa by several kids. What is the MAD of the data represented in the dot plot? Well, MAD, if you recall, is mean average distance. So let's start by finding the mean. By doing a little mathematics in my calculator, I determined that my mean is going to be 5. Now, I have to find the mean average distance. So mean is equal to 5. And I want to find the distance of each point. So this point is 2 away from our mean, which is 5. This is 1, this is 1, and this is 2. And we have 1, 2, 3, 4, 5, 6 that are 0 away. So we're going to say 2 plus 1 plus 0 6 times. I could have just written 0 times 6 plus 1 plus 2 divided by the number there are, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which gets us 3, 4, 5, 6 over 10, which is 0.06. So our mean average distance is 0.06. And I calculated the mean by adding up all of my values and dividing by the number there is. I calculated the distance by subtracting each point from the mean and taking the positive value. Then I added up my average distance for every single point, including those 6 zeros, and divided by the number of points that there was. I got 0.06. Our units are marshmallows, and that gets us with the answer A. If you have a hard time doing this, you should go back and watch some old videos to make sure you're fluent on this topic. That was covered in Unit 1. Problem 6. Here is a data set. After studying the data, the researcher realized that the value 100 is meant to be recorded as 15. What happens to the mean and the standard deviation when 100 is changed to 15? Well, we're going to change this to 15. The mean gets smaller because whenever you get rid of an outlier, our mean is going to get smaller, or it's going to go in the direction of the rest of the data and not the outlier. And the variation is going to get smaller. So SD is smaller too, because your deviation from the center of this data suddenly becomes a lot smaller. For the original data set with 100, would the median or the mean be a better choice of measure for center? Explain your reasoning. Well, 100 looks like an outlier. If you have an outlier, it tends to skew the mean towards the direction of the outlier. In this case, because our mean is skewed towards the direction of the outlier, the median is a better measure of center. So for this set of data with 100 in there, I would say the median is a better center of data. Pause the video now if you have to stop and write down what I said. If not, we're going on to problem number 7. A coach for a Little League baseball team is ordering trophies for the team. Players on the team are allowed to choose between 2 types of trophies. The gold baseball trophies cost $5.99 each, and the uniform baseball trophies cost $6.49 each. The team orders G gold baseball trophies and U uniform baseball trophies. Write an expression that could represent the total cost of all trophies. So, U is uniform trophies. I don't know what a uniform trophy is. And then we have G, which is gold trophies. Gold trop. And then we're going to have the cost, which we're just going to call C. So we need an expression. The cost is going to be U times the number of trophies you get, which is the number of trophies you get, which you multiply by the cost. The uniform baseball trophies are $6.49 each, And I'm just putting the numbers in front because that's standard practice to put the numbers before your variables or your letters. And then G is the number of gold trophies we get. The gold trophies cost $5.99 each. So it will be $5.99 times G. And that's our expression for the cost. Let's go on to the next question. The robotics team needs to purchase $350 of new equipment. Each of the X students on the team plans to fundraise and contribute equally to the purchase. Which expression represents the amount that each student needs to fundraise? Okay, let's get started on this question.